Good morning. I hope you're doing well. I am doing very well. It's been a couple of weeks since we've seen each other. Well, since you've seen me, I guess. And yeah, so I was overseas. I was in Europe for a couple of weeks, which was a lot of fun. It was very good, but I'm very glad to be back and to be back on Jugglebot. There have been a few very exciting things that have been kind of like slowly building in the background, and finally, one of them at least has come to fruition, and I'll be filling you in on the details of another one towards the end of this stream. So, as you may have guessed from the thumbnail of this video, finally we have slow-mo, and it is amazing. So, I've got a setup here where I've learned a lot of things about slow-mo and in particular camera lenses in the last couple of weeks, or the last couple of days while I've been playing with this. And yeah, I've got a setup here where I can show you like one thing in real time, which is cool. And then I want to show you some recordings that I've taken before, because it's a little bit tedious to move things around. And I'll talk about that in a bit. So we can see, if you can see my room here, we've definitely had a bit of a change of scenery. We've got slow-mo camera. Let me zoom into it on the left one. Let me actually just change this to this one. Yep, so we've got very, very high-speed camera. I'll put a link in the description for what this camera is. I forgot to do it before, but it's the free fly wave camera is what it's called. It's very, very good. It's amazing. For the lens, I have a macro lens, which I have come to learn is perhaps not exactly what I wanted, but I can't return it, so we've got what we've got. And it's great for doing very, very, very close-up shots. And then it turns out, high-speed like photography or videography needs an absolute shitload of light. Like, of course, every single time I've heard someone talk about slow-mo, they're always like, oh yeah, it needs a lot of light. Like, you need so much light. But like, my God, it's nuts. So I have these two lights where once I turn these on, boom. You can't even see me anymore. This is nuts. And that's like what is necessary to have the shot work. So let me put this back. Like, look at that. Jugglebot is like, this camera just cannot deal with that amount of exposure. But that is exactly what's needed for the slow-mo camera. So this is the shot straight from the slow-mo camera, so like I can block it off with my hand. And this is exactly what we can see. And it's so good. Like, this interface is so nice. Like, so I can go up to 4K. I can go up to 4000 by 3000, which is kind of a weird aspect ratio in my opinion. And the max frame rate I can do here is 300 FPS. Is the top at 4K, which is pretty good in my opinion. And if I reduce it down, if I go down to 2K at like the rectangular aspect ratio, we can do 1049 frames per second. And the maximum frame rate that we can possibly get to is if I have a super, super narrow little beam, and I don't really know what I would be recording if I had such a tight little slit. Let me put me on here as well. Yeah, I don't really know what I would do with that, but if we can find something, we can go up to 260 FPS, which is nuts. Absolutely insane. So fast. But I think this should be good. 2048 by 1408. Yeah, so let's see it in action. I love that I can take a recording and then immediately, and the recording can be as long as I want either. It's not like, I think older slow motion cameras had a limit of like, you can only record for like a couple seconds and you had to like press the trigger just before you were recording or just afterwards. Let me turn these lights off as well. Yeah, so you had to like set the record, like you had to be like on it to like start or stop the recording. This camera, I don't need to do that. I can just press the record button, leave it going for as long as I want, and then press the record button when I'm done. It's so good. There's actually there's an interface where I can put a cable in. I've got the cable for it, but I haven't actually gone to set this up yet. So I can just like chuck this little connector in, and then I can actually start and stop the recordings just with like a 5-volt signal. So I'm really keen on the idea of hooking this up to the Jugglebot computer, and then that way it can start and stop the recordings like exactly as interesting things are happening, so that I don't have like a shitload of extra footage. Yeah, it's so good. Of course, like there is a limit of storage, but this camera has 2 terabytes of SSD on it, like natively. And originally I thought that that was like an absolute insane amount, and like it is, but in reality, if I'm recording at the maximum frame rate, it will fill up that hard drive in 19 minutes, which is nuts. 19 minutes for 2 terabytes of like writing data. It's insane. So understandably, the camera gets quite hot and it's got a little fan. You probably can't hear it right now, but yeah, it's a nuts camera. Anyway, let's get some throwing going. Of course, because this is a macro lens, you can only see like the tiniest little piece. So I've got it currently focused on the back on the spool that you saw just a second ago. And this is one of the areas that I was pretty keen to have a look at. And yeah, of course, as Jugglebot moves around, that little zone that it's focused on changes, and so I'd have to move the camera around. So what I'm going to do now is just boot things up and then have it throw in a way that it wouldn't normally throw when it's just like down at its lowest position. Just to show you the proof of concept. So it's currently homing, or it's not homing, it's turning on and like index searching. And now we can home, and it should go back to being in the center of the frame. We can prepare the hand for throwing. And I'll put a ball in the hand just so that it has something to push against. And then we can throw. Oh shit, I didn't record. Alright, I started the recording a little bit late there. But we can still see straight away, straight after this recording is taken, boom, look at that. And we can go in like even slower, so I can like scroll through this. So now I'm going backwards at 1 speed. You can see that bar at the bottom. We can go even slower, go forwards at 0.25, which is like, I guess the equivalent of like 4,000 FPS. It's so good. I find this so satisfying. And it just slowly ekes up to the top. But, so that it's, or to I don't know, keep things interesting, I want to show you some shots that I've recorded before, because yeah, I've been learning a lot of things, as I said, and one of them is that scrubbing through this footage can take a little while, and like finding cool, interesting things can take a little while. Of course, if we want to be investigating a particular phenomenon going on, then that whole set of footage is going to be cool, but like for now, just because we're like stuffing around pretty much, I want to show you some things that I've already got. So to do this, I have to plug this into my PC with USB-C cable. And then we can actually view the footage in like proper 4K as well. So what we were just viewing then, I don't actually know, I think it's 1080p, it outputs over HDMI, but in the app, which I have, it doesn't auto size. It's so triggering. If I like drag it around into the different windows, it doesn't fit those windows properly. So let me just change this to this. Hopefully this works. So I think that one of the coolest bits of footage that I got, why isn't that showing? Oh man. I guess I should have tested this before, but I thought it would just work. All right, I've got to resize it manually, and then I can drag it down here. Yeah, this should work. Yeah, this app is cool, but it's, I don't know, it's definitely a work in progress, it feels. Yeah, so this shot in particular, this was a strange one. So I got, like, this was last night, I was just having Jugglebot do some basic throwing and catching, and something really strange happened. I have no idea why this happened, but when it went to throw the ball, it like jittered a bunch. It was like, and then it threw. And then like the rest of the throws were all fine, but that first one was like extremely jittery. No idea why, but luckily I caught it on slow-mo. So we can see exactly what happened. And it is so cool watching it. Of course, there's a lot of preamble because I started recording a little bit early, but I love watching this sequence play out. Once we get there. Let me get rid of me as well so you can see the whole interface. Yeah, so it starts off, this is at 300 FPS as well. You see up the top right corner, it's got information about the clip. So it started to go up, and then it just does this weird like jiggly motion, and the hand seems to deform by so much. And also like the camera is in a static position, so the camera is definitely not moving. Let me play it through at normal speed, at 300 FPS. And this playback is at 24 FPS. But that's so strange. And like everything is jiggling so much. The hand is flexing a lot more than I would have thought it would. You can see the actual, like the rail of the platform, this here, you can see this deforming as well as it moves around. So that means the entire upper stage of the platform is moving just as a result of this hand jiggling just a little bit. It's nuts. There's a lot more vibration going on than I thought. And then the ball just like completely flattens when it gets thrown. It's just like turned into a pancake. It's awesome. It's very interesting. But yeah, unfortunately, because this is a macro lens, I can't get the entire stroke of the hand in shot at once. So I can either get the bottom or the middle, like this one is, because I was trying to capture the catching of this one, but I think I was a little bit off. I think the catches happened a little bit lower. Yeah, but it's pretty bang on. Or I can get the very top. And I've actually, I picked out some good ones. Let's go to this clip. And we should go up to around 3,600. I love watching that. It's so majestic. And of course it takes a while for the ball to land again, so we can skip ahead a bit. This was interesting. This is something that I need to check on the telemetry from the hand motor, but for some reason, I'll play this through properly. So the ball is thrown, it chills out for a bit, and then for some reason, it moves up just a smidge. Just a little bit. There needs to be like a fast forward mode in this app. It was actually very hard to spot. That I don't know why that happens. It just moves up just a little bit just before it catches. And then of course the ball comes in for an almost perfect catch out of frame, unfortunately. And I've got one more cool clip to show you, which was the spooling and unspooling, which I love. And this was interesting. So I took the hand motor out and put it back in again, and I'll explain why I did that in a second. But I noticed that when I was manually sliding the hand up and down, sometimes the string would not coil and uncoil. Like the way that it normally goes is that bundle of string will basically move along the barrel, the drum that it's like wound around, the spool. And for some reason, and that's always worked perfectly fine the whole time I've been using this. Like every single time it always just like goes nicely back and forth, back and forth. But for some reason, once I replaced the hand motor 2 days ago, every now and then the string would spool back over on itself. And because this system is so sensitive to that spool diameter, it actually jams itself if the string starts to like spool back over itself. And I don't really know why that's happening. Unfortunately, well, I guess maybe, I don't know, better or worse, I couldn't get that. It didn't happen while I was recording at all, but I did still get some pretty cool footage. So this is at 1760 frames per second. And it's very interesting. I find, so I'll play through normally, and then I've got some things to say about this. And so in this particular throw, so this was a throw, and then I don't know why the hand's going back down just a smidge, but because this was just throwing the same way that I have it here, where I've just paused it, because this is throwing the same way that I have it here, it's not perfectly level, and so the ball actually was not caught. And so we have a kind of funny, let me skip ahead a little bit to 4300. there's a kind of funny moment where, so the ball collides with the hand and you can see the whole thing kind of shake. And then the hand comes down empty because the ball didn't land in it properly. And at perfect timing for the comedic effect, we see the ball come down. Ian, yes, this spool is 3D printed. Yes, which does, it looks to me like the spool is not perfectly the same diameter the whole way across. Like it looks like this region is a little bit thicker than this region. And unfortunately, I don't think I can zoom in on this app. But yeah, but I don't know if that's just because the string is coiling weirdly. Yeah, but one thing that I noticed that was very, I don't know, unexpected to me is that if you watch the string that's going up, it gets kind of like pushed every revolution of the drum. It's not, I would have thought that this would be a continuous, as it's spooling on, it would be continuously brought across to the side so that it like spools on the next round smoothly. But that's not what seems to be happening. It seems like every revolution, it just gets nudged by one diameter of the spool, of the string further across. I don't know. It's weird. It's very strange. And yes, there's a lot more for me to do here, and I'm very, very keen to be playing around with it more. It's very fun. Definitely requires a lot of setup though. There's a lot involved in getting slow-mo to work nicely. But it's super cool. If anyone has any ideas of things to capture, I haven't actually done much non-Jugglebot stuff. And I'm definitely keen to do like water dropping in a bowl and that sort of thing. I probably won't publish any of that here, but I don't know. If there's anything you want to see, or if there's anything in Jugglebot that you think could be cool to watch in slow-mo, definitely let me know. Cool. Yes. So slow-mo is awesome. Of course, I still have a lot to learn. Turns out filmography is like a whole thing, and I know very little about it right now. And so all of this has made me realize that there is one particular shot that I really, really want to get in slow motion. And that is a shot of the camera being perfectly centered on the ball, and then when the ball is thrown, the camera moves up with the ball, tilting in some fashion to get like a cooler angle on the ball. I'm thinking moving up, so it's like, if this is the ball, you can move up, track the ball, and then when the ball reaches the top, it tilts up to like look at it from underneath, or tilts down to look at it from above, and then tracks it back down again. And like at the end, I think having like a tilting from above view of the ball landing in the hand would be like, wow. I have been having a hard time getting this idea out of my head for the last little while, like 2 weeks or so. I think it would be absolutely amazing. So to this end, I've gone on a little bit of a tangent, but it's not full tangent, and I've designed a mock-up rig of what this might look like. So my thinking is I can use 2 C aluminium extrusion beams, and these will obviously be a lot longer than this. It's just unwieldy to like manipulate a model where some things are like where the aspect ratio is like really long. And there'll be 2 motors. I have been meaning to draw the lines of where the strings would run, but I'll draw that in, I'll fill that in just a sec. I'll show you like roughly what that would look like. But the idea is that these sliders can move up and down to move the camera, and then on these sliders there's like an angular joint, so this can move back and forth. The fact that the camera can slide back and forth along here is just for like using different cameras. Like if I want to do it not slow motion, if I wanted to just use my normal camera, or if I have a different lens later on or something, I want to have this be as like agnostic to the camera and to the lens as possible. So I've been looking around, and it turns out there are these like little base plate things that people use for making like really big rigs, like camera rigs. And I've been thinking of using that same sort of setup so that the camera can just like slide onto these 2 rods, and you can put whatever camera you want on here. Ian says, would it be easier to keep the camera stationary and have a rotating mirror? Potentially. That's a very interesting idea. Maybe. I'll have a think about that. Yeah. Yeah. One thing that I am very, so yeah, just to like top up or to finish the explanation of how this would work. One of these motors would handle the up down, and the other motor would handle the rotation. And because of the way that the belts would be wound, these two motions would be interconnected. So the motor that's doing the rotation would have to move even if the camera is just staying flat and moving up and down. But I don't think that should be too bad, because if I'm using ODrive Pros, or any ODrives really, they have extremely precise control of the motors, and I should be able to keep them in sync. Yeah, so the rough idea of the way the strings would work, let me draw you a quick sketch just to show you my plan. It's extremely similar to what StuffMate here did in his basketball launcher thing that I mentioned in my last video, where on one side, the belt basically just goes up and down and then connects onto, as this goes around the motor, this would connect onto like that, the linear slider. And then on the other side, it's very similar, but the belt goes up, down, out like that, and then back down. So this little kink part will attach to the axle that the camera system will rotate around. And yeah, so it should be pretty straightforward to get that set up, I think. Of course, I've been wrong about these things before. And yeah, I think it should work quite well. And these two motors should have enough force to easily move the camera at the same speed that the ball moves, so that I can actually keep the ball in the center of the shot, even for like a 1 meter throw height. It should be able to move the camera fast enough to keep the ball perfectly in the middle, in theory. I just think this would be an amazing shot. And of course, because of the way that I've designed this, the camera will be able to go like fully upside down. And I think it would be so cool to have a shot of the ball like coming over the camera tracking it, and then going into Jugglebot. Like, there's so many options with this. And of course, like I can do like linear sliding in and out of things. It definitely opens up a lot. But of course, this is a fair bit of a tangent from normal Jugglebot work. However, I've been kind of like rationalizing this in my mind, because this design is basically the training wheels version of what I've been thinking of having the next version of Jugglebot being, where I've been thinking of having a 2D frame like on the ground. Obviously would have some depth, but like mostly just like a big square. And then inside that square is some sort of launcher that's similar to what we've got right now, and that can move around, and then it can also tilt in 2 degrees, or about 2 axes. And this camera system is basically that, but like much simpler. So I'm thinking that by doing this, I will learn a lot more about that sort of system, and using belts. Like, I've never used belts before in anything, so it'd be very handy to have some experience with those before going into like a proper big design. So it feels like this would be like a warm-up exercise almost for like potentially for the next version of Jugglebot. It will definitely inform a lot of future design decisions, which could be very helpful. And I will get a pretty sick camera rig out of it. Which is definitely not nothing. However, I have one main concern that I can't really think of a good answer for right now. And I'm very curious to know if anyone has any thoughts on this. So, of course, because this will be moving quite quickly and will be rotating quite quickly, I want to have the camera's centroid, and like the camera and lens, like this whole assembly, I want the centroid of all of this to be at pretty much the exact point that everything is rotating around. So to that end, the best idea that I could come up with, sorry, I need to cough. The best idea I could come up with quickly was just to have a bunch of holes in this rig. Also, I would be intending on making this part at least out of metal so that it doesn't break my camera. That would be very upsetting. Yeah, so these 4 holes, maybe more, maybe less. I don't like, this is obviously a very quick sketch right now, will allow to position that camera at slightly different heights. And then because the camera's on rods, we can slide it in and out to get that centroid pretty as close to bang on as we can. Yeah, but there's a problem here, which is that the way that I have set this up right now, we have one motor doing up and down, the other motor doing the rotating, and these are on different sides. And I can foresee a potential issue with, like, if the left motor is the up-down one, if that is applying an up-down, like a vertical force to this set of sliders, like there's two on each side. If that pulls this up, there will be nothing pulling up the right-hand side one, and so we'll be relying on the stiffness of this entire chain, like a link from here to here to here, to then pull up the right-hand side. So I'm kind of like, I don't know, I'm afraid that this will introduce a bit of like wobbling, which of course will not be good at all. Like, we really don't want that. We want this whole thing to be moving up together at the same time. So I've been contemplating, like, maybe I can route the belts from the up-down one over both sides so that both sides both lift up at the same time. But from what I can tell, that's going to massively complicate the belt routing, which again could maybe be a good thing because that will help even more with like planning the next version of Jugglebot, because that's definitely going to require some pretty intense belt routing if I go down that option. But I don't know. It would be great if I could just like stiffen this, like join this link to this link, but I can't figure out how to do that in such a way that it still allows the camera to rotate like 360 degrees. Yeah, it's tricky. And I'm, very interested if anyone has any suggestions on this. Of course, this would also be mounted to a solid base, and yeah, that'd be good. Yep. Also, the link for this CAD model is in the description. So if you want to check it out, then click that link and you can see the model, normal Onshape stuff. Yep. I've also, I want to mention this as well. I've made, sorry, I need to get familiar with my cameras again. 7, that's the one I want. Where's my remote gone? I've made a perfect little nook for this over here. So if I move out of the way, my printer station used to be here, but because this is a macro lens, it needs to be as far away as possible to see as much as possible of the shot. And so if I put the camera right at the back over here, that's like a good size to see like a good amount of Jugglebot. And this would be perfect. If I could just have this like this slider rig just like here against the wall, it'd be perfect. And it can do all the shots that I want it to do. Yep, it'd be good. Cool, okay. So that's my thoughts on slow motion. Definitely got a lot to learn, but it's so good. I love it. Run the belt underneath rather than over. I'm not sure what you mean by that, Ian. Could you draw a sketch and send it on Zulip? That'd be very helpful. Next thing, the hand motor should finally be safe. Better late than never, I guess. What I mean by this is, for a long time, we've been aware that the hand motor, which I have put all of the ones on my desk away so I can't show you, is a very small little brushless DC motor. And it's doing a lot of work by throwing and catching the ball. And we've been a little bit cautious of the fact that this may cause quite an increase in temperature. And yeah, that obviously has problems if it gets too hot. And if you saw my last video, you will remember that there was one point actually where I accidentally unplugged the entirety of Jugglebot while it was throwing, and that led the hands to just basically crash into the end stop and just try to keep on moving upwards. Of course, it overheated very quickly and let out a lot of magic smoke. Not good. So that's why I went through, well, that's part of the reason why I went and took out the old hand motor, which actually still worked. So I've kept it in like a bag, and I've written a note on it saying this still works, but it lost like a lot of magic smoke. But it still works. So, but in any event, there's a fresh, brand new motor on the hand now, and I have finally put in a thermistor so that we can actually tell the temperature of the motor, which is very nice. And what I ended up doing was, so this is the thermistor in here, this little like striped, it's got a gold stripe, an orange stripe, and a black stripe. And the two cables run out, and that's like the blue and the white cables. I found this perfect little nook where I can slide it in underneath this like bracket, and it seems to stay there pretty well. So the thermistor is just in there. After covering it in thermal paste, that's roughly what it looks like. And it seems to be doing the job. So to test this out, I set the limits in the ODrive software to, I think I set the soft limit to 60 degrees, which is the limit which is the point where the current starts to become limited to stop the temperature increasing. And then I've set the hard limit at 80 degrees. So if it ever reaches 80 degrees, the motor will just turn off. It'll send an error and it will stop doing what it's doing. And so to test this out to see if it was actually working, I sent in a command of always move at 1 revolution per second, and it just keeps spinning. And then I just held the motor. So you can see I started to hold it at like around here or so, and the temperature starts to go up. But then once the temperature reaches like 72 degrees or so, and I could actually feel this, it stopped putting as much force into the motor. So it started to just like limit how much current was going into the motor in an attempt to limit the amount of heat going in, which actually seemed to work really well. So you can see I let go of the motor at where this step is. So I let go like here. But even before then, the temperature was actually decreasing before I even let go. While it was still being blocked, the temperature was actually going down. So that's very good. This gives me a lot of confidence in using this system and like pushing it really hard to the limits, because now I feel pretty good that the motor is not going to like catch on fire or destroy itself. My question is though, I don't really know what temperature limits to set. So I've been reading about this online, and some people seem to suggest that 60 degrees Celsius is a very safe limit. But that feels very, very conservative to me. It feels like we should be able to go hotter than that, but I don't really have enough experience to know for sure. And I wish that I had some sort of thermal camera so that I could actually measure the temperature of the motor when it was burning up before. Unfortunately, I don't yet. But yeah, so I don't actually know how hot it got before, unfortunately. And the O-drive default is 100 degrees for the soft limit and 120 degrees for the hard limit. So this, again, the soft limit is where it starts to limit the current, and the hard limit is where it will just trigger an error and turn off. This is what it's actually currently set to. I changed it back to these limits after doing that test before, just because I didn't want to be holding a 100-degree motor. But this feels a bit too hot. So I don't know. If anyone's got any suggestions for what temperatures are safe, I would very, very much love to know. Yoroka is saying some sort of differential kinematics where moving both belts results in moving. Yes, yes. So yeah, so you're saying back to this is for the camera thing. Yoroka is suggesting that there might be some way to have both belts contribute, like if they both work together to move it up, and then if they both move down, it moves down. If one goes up, if one motor spins one way and the other motor spins the other way, it'll rotate in one direction, and then vice versa. If the motors swap, it'll rotate in the other direction. I agree. This feels like it should be possible. I have gone through a lot of iterations of like trying to come up with different ideas. You can see one of my first drawings here, which I feel like should work, but would have very poor like precision, I think, and it wouldn't be able to do full 360. I've gone through a lot of different versions of this, some with like one-way bearings, but no matter what I do, it seems like there's always ways that the system can get jammed and have like the motors fight against each other, or there'll be like one type of movement that the whole collective system just can't do, which, yeah, it feels like it should be possible. I agree, but I haven't been able to find it yet. If you have this cooking in the back of your mind and you come up with anything, I would very much love to know. Cool. Okay, so the hand motor is good, which is a big relief. I've also, you can actually see in these pictures, I've also put on the new aluminium magnet holder, which is very nice. It doesn't need to, it probably, yeah. When I took off the old one, I was actually very pleasantly surprised that it wasn't wobbly at all. Like the old 3D printed one was perfectly straight. I think that I had changed it to be a little bit thicker than the initial version, but yeah, the printed one seemed to be holding up fine. But I just changed it for the aluminium one anyway, just because I've got them and I may as well, and it's definitely going to be stronger than the printed one. Cool. All right. So the next thing is finally we have a way to scale the input velocity, which is so nice. So people may remember that we've had an issue where I've been having to, when we're controlling the hand motor, what we want to be doing is telling it, go to this position, you should be going at this velocity and you should be applying this much torque when you go to that position. Thankfully, O-drive, like this is a very, maybe not super common, but this is a fairly common way to control motors. And so the O-drive, like the people who develop O-drive have made it so that you can just send a single message to send out all 3 of these data points to the motor. But unfortunately, up until now, there has been no way to scale the velocity that you're sending to it. So you could only send it up to 32.7 revolutions per second, up or down. And John actually collected this, well, in his process of figuring out what the issue was, made this graph where we can basically send an increasing velocity, and we can see that every single time it gets to 32.7, it clips and then gets like reset back down to 0 or down to like negative 32.7, then goes back up and gets clipped, goes up, clipped. And this is no good because we want to be controlling that motor at very high speeds. I checked the telemetry from some of the lower throws and it was going at like 90 to 100 revolutions per second, and that's at a fairly low throw. So if we're throwing the ball super high, we're going to need to be going way faster than 32.7. This is how it was set up before, where we could send the input position, we could send the velocity feed forward, and we could send the torque feed forward, but the velocity and the torque were limited. That, like, their default unit was the only unit that it could be. So you could only, so this is what made us need to, this is what set the limit, effectively, of 32.7. I mean, there are a couple ways that they could have gone around this, but now, thankfully, they've changed it so you can change the scale of these numbers, which is great. And I may be seeming to get excited about something that doesn't really seem to mean much, but this is so good. This message is being sent out to the hand motor at 500 hertz, 500 messages per second. And that's like by far the fastest, the most frequent message that's being sent across the CAN bus. And currently I have 3 of those messages. Now I will be able to cut it down to just 1. So we'll be cutting out 2/3 of the most frequent message, which should open up a whole lot of bandwidth, which means I'll be able to send a lot more messages over the bus. Up until this was done, I was a little bit worried that we would be able to control the legs with a similar sort of system because there'd just be too many messages going across the bus. But now, I feel pretty good that we should be able to control all of the legs at like maybe 200 hertz using the same approach as this, and then the hand at 500 hertz, and we should have a really good control of everything. Really fast, very tight control should be able to. Yeah, it's very good. It's very, very good. I'm very keen for this. All right, so the final thing is a very exciting one. Is the Jugglebot will pretty likely be meeting mocap soon. Mocap being motion capture. And this is huge. I don't know if anyone has seen my last video recently. Stuffmate here actually commented on it saying that he was just like, you need to get motion capture. Like your project will benefit so much from having motion capture. And I've known this for a long time, and I've always just thought it was like way out of the budget for this project. But I've been talking with a couple reps recently, and it turns out it's actually cheaper than I thought. Maybe cheaper is not the right word. It's more affordable than I thought. It's definitely not cheap. But it actually should be possible to get motion capture in this room so that we can track Jugglebot extremely precisely. And I'm very, very, very excited about this. My problem is I don't know which one to get. So I'm in discussion with reps for 2 different companies. One of them is OptiTrack, which is the system that Stuffmate here uses. I'm fairly sure he uses like the most primo cameras you can get from these guys, which I guess doesn't surprise me too much. I would be getting the 13Ws, and I've got a link for both for this camera and the other one that I'll show in just a sec in the description, so you can check them out if you want. So there's OptiTrack, or there's Qualisys, which is the Miqus system. Both of these, honestly, either of them would work very, very well. But there's slight differences to them, and I've been doing so much like back and forth between them and trying to like figure out what system is best, like where I would put them in the room, and like how I would actually integrate this with my Jugglebot code. There's so many things that have to kind of work together for this system to work the way that I want it to, and it's definitely it's been quite a long process of like trying to see what this is all about. Yeah, so the reason I'm mentioning this now is that if anyone has any experience with either of these systems and has anything at all that you think might be useful for me to know, please let me know. These systems are almost exclusively used for people doing like physiotherapy tests, and so pretty much everything that I could find online about these are for that target market. It's like, oh, get your body tracking suit on, get your force plates on the floor, and like do your tests and whatever. And like, there's all this stuff about like fitting like a skeleton to the tracking dots and everything. It's like, I don't want any of that. I want to track a juggling robot. And I guess perhaps unsurprisingly, that's not a very common use case. Yeah. So any thoughts are very welcome. Cool. And that's all my updates. There's lots of qualitative things, not too much quantitative stuff, which I actually, there's one more thing I want to talk about before we've got John on the line, and he's got some very exciting things to show us, which I'm very, very keen for. But there's one thing, my plans for moving forward is what I want to discuss. So I've got a couple options, as always with this project. There's like a million different things that I could do that would all be valuable, but it's like, which one's the best? I think the most valuable ones right now would be either the camera rig to test out that whole system and get familiar with using belts and to get familiar with that mechanism of like combining linear motion with rotary motion, because that's going to be super important for future versions of Jugglebot, potentially. So that's one option, is to work on the camera rig. The other option is something that I am conscious that I've kind of been like low-key putting off, is that, but it's probably more important, is that Jugglebot's brain really needs an overhaul, and I need to go through. My plan is basically just to start from scratch. There are a couple ROS nodes that I will probably keep because they don't really need to change, like the inverse kinematics of the Stewart platform, the Space Mouse control so that I can control Jugglebot with Space Mouse. That stuff probably doesn't need to change too much, but for the most part, I'm planning on just scrapping it and starting fresh. I'm a little bit nervous about this though, because I want to do it properly, and it seems like writing code properly is a very different exercise to what I've been doing so far. So I'm definitely, cautious of my abilities to do this. But I guess that's kind of how the whole project has been. So yeah, I don't know what I'll do. We'll see. But I know that as soon as I get mocap set up, I know that I'm going to be like in mocap mode for like weeks afterwards. There's so much stuff that mocap would make possible. So I'm kind of wanting to do the code overhaul now, because like the mocap stuff is going to take a couple of weeks to like arrive. Once I actually find what I want and buy it, it's going to take some time to actually get here. So I'm thinking that if I do the code in that interval time before mocap arrives, then I can get the code all hunky-dory, all clean, nice, fresh code. And then when mocap arrives, we can go crazy and just like add that into the fresh new code. Yeah, as I'm saying this, I realize that's probably the right move to do, and the camera thing is a bit of a procrastination. Yeah, all right, I guess I'll probably do the code. I don't know. Any suggestions, as always, very welcome. Cool, that's enough blabbering from me. We have John on the line, who's got some very, very cool stuff. So let me put that there. Let me make that full screen. Let me change this. So hopefully you can hear me, John. I think my camera view for you is very crap. It's very slow. I'm not really sure why. And let me do that. There we go. All right, I will unmute you. So you should be, I don't know, audible? I can, but I don't know if you're coming through. Ah. All right, I think so. Say so. Yes. All right. So people online should be able to hear John. Yep.
Yeah. Can you hear me?
I can. I think you're coming through.
Okay. All right. We'll give it a shot. My video is kind of slow through the Google Meet, but see if this works. Maybe I'll just switch to the video share, and maybe that will screen share. we're gonna show off.
So for full
And I
full
apologize.
context here, John has been working on a potential new version of Jugglebot, which is a cable robot. Which I'm glad that he's come around to a cable robot, because cable robots excite me a lot. And yeah, Delta robots not so much. Cable robots are like, from what I can tell at least.
Yeah. So first of all, I have a 2-year-old helper right now, so she's gonna come in and out. So my apologies.
No.
Yeah. So she's been helping me bolt together the frame.
Nice.
Let's see. So I've got the CAD up here. This is the messy CAD that shows the strings going to the center platform. Let's see.
So I've actually got a question about that platform. Is this model that you've got right now, is this intended on being like a rough, like first approximation sort of thing, or like in particular, I'm thinking of like the depth of that piece, like
it's just a placeholder. Yeah.
So like in the final version, would the strings be spaced apart at all at that intersection point?
That is really digging into the core of the fun puzzle that I've been puzzling over, is how to do that. I was going to do a post and then you asked me to come on, so we'll just kind of try to walk through it live.
Yeah.
Maybe save that for a second, because that's digging in a little bit.
Yep.
So I threw some stuff down to kind of talk about how I got here. Cables are super fast. There's super low inertia. I think just in terms of like getting to a hardware solution that is capable of juggling 14 balls, I have been puzzling over like what is the reasonably priced ultimate solution that we'd be able to put together and try to build a Jugglebot that's very, very capable.
Yeah.
And this is what I've come up with. Try to talk a little bit to the sort of magic of the kinematic. So that the upper strings, as you're accelerating the ball up, the motor's gear ratio is sort of increasing. So what's happening is you have like
because
this variable gear ratio because the angle is changing. So think about it, the very top can't make it go up anymore. The strings are like locked at that length and they're kind of passing through that, like it inverts the mechanism. What's cool about this is I think as you're accelerating up, the motors have to slow down, but you're still trying to drive them up. So it takes the energy that went into the motors and puts it into the ball and in the hand. So it kind of flings it up, and you kind of like picture like, I don't know, like a water balloon launcher or something. Like you kind of like pull them out sideways. You can get it to go.
Do you remember
kind of accelerate up?
The video, the earliest design that I had on YouTube, it was utilized that same approach where I don't want to try to find it. It's going to be hard to find the video now, but it had like wheels where the cables wound around, and like it made use of that same, like the fact that as you go higher, the ball travels faster. And I actually amplified that even further by having the spool that the string was wrapped around. It was kind of like like a spiral sort of shape, so that it got wider the further up it went. So it went like, it really, really like popped the ball off. Unfortunately, there were a lot of other problems with that design, but yeah, I really like this idea of like yanking the strings to just like shoot the ball out.
Yeah, and I definitely don't think you want to go all the way to the top, but I think there's a little bit of benefit to like working in the top half of the range, and then you release it, and then you get rid of the ball, so all the inertia drops a lot, and you'll be able to stop the hand pretty quickly at the top using the lower strings. So I think it's going to help, like for a given stroke and motors, help to like throw the ball higher, and hopefully at accurate speeds. But I think it's interesting, and that's what I've been trying to chase, and trying to do this with a rigid link delta or something like that. Like where I originally started was something like an upside down delta kinematic 3D printer looking thing. So 2 links on each of these legs facing up. So not like it's the hand up in the air. It's kind of appealing to like what it looks like. And you have a little base with these actuators and little arms or linear rails to drive that, or three rails kind of around in perimeter. that they ride up and down on. I think you could make that work, but it doesn't have the same, like, you can't really get it to do this accelerating thing that I kind of like.
Yeah.
And the other, when you flip it around, the catch is also interesting, because the thing that we were trying to do before with the low inertia hand, if you just park the hand all the way up at the top and put it where the ball's going to come, there's effectively no inertia, just the mass of that platform that the ball's crashing into, and then it starts to catch it.
Oh, because it's at the top, the motors have, like, there's a really high leverage on the motors. So even if they do, even if they are quite large, it will still push against them without much issue.
Yeah, the upper motor's inertia doesn't really reflect into the ball very much at all.
Because
and then the lower
like when it's at the top of the stroke.
Yes, and then the lower ones can't push up.
Yeah.
Their job is to just keep the strings tight. So just the whole like negative side of the cable robot land is managing string tension, and the control, I think, has some interesting challenges. But I think it's all doable and part of the fun. But those don't really play, like, only like those are really like kind of steering, and then the upper ones are really doing all the power when you throw in and catch.
Yeah.
So that's one big thing. I'll say a quick thing about another is that there are typically 8 strings in cable robots that have 6 degrees of freedoms. It seems like too many, but it needs to be redundant. And I was not convinced at first.
So my understanding of that was that it gave like a much larger range of motion, and allows the end effector to reach further into like the corners of the frame.
It does. So being redundant helps with that, because then you can have some of the strings sort of become unfortunate from a kinematic perspective, but you still need them to all participate, because they can only pull. There's this like problem where you need the redundancy to end up controlling that wrench closer. So like being able to put the moments in any direction without it sort of flipping through or going negative tension on one of the strings is kind of the problem. And I don't totally have my head wrapped around it, so I picked up that textbook and I'm starting to puzzle through that. But the key with this guy is that by giving up the yaw degree of freedom, which, let me throw up a different picture, because you don't need it.
Yeah, right. So if you have 6 degrees of freedom, then 8 strings is good. But we only want 5 degrees of freedom. Yeah. So then how many strings needed? Surely not 7.
And like, they kind of start building up from the beginning. So if you have just like a planar version with 3 strings, you can do yaw and X and Y. It doesn't seem very good, but like you can kind of make that work for some amount of range of motion. So this is a version that they show in the book where you got 3 on the top and 3 on the bottom, and it's at, that's because I shared the window and not the screen, which isn't very helpful.
Is this textbook, why are you just getting this up? Is this textbook good? Like how good? Because I'm very inclined to get it, but it's like, $275 in Australia.
You know, I have to check what the price is, because it is less as a Kindle book in the US, and I'm surprised that it's that much more.
I think it was
something that I don't appreciate being in the US, I guess. I don't know.
Yeah, well, everything in Australia is so expensive, but I don't know if it's just like because it's an academic book or not, but some of these, like the more esoteric books, are ludicrously expensive in Australia.
They do get expensive. I'll say these like really good gems of textbooks on like precision and machine design, and this one's been pretty good. It's a good like overall context of how they got there. And there's others that like collect papers and things, because like cable robots aren't that old. They were kind of like this novelty thing, and then they realized that you could use them for all this stuff. So like the camera bots that go over sporting events and stuff is like really the big application for them. And there's only 3 typically, so those don't have the kind of hangs. They rely on gravity to stabilize the moments, and they put a gimbal on there. Some of them, I don't know all the details, but like there's gravity stabilized, and then there's these that are like fully constrained. So like tons of cool paper research on how to control them and be very accurate and compensate for all the interesting errors that crop in. But so I guess back to this configuration thing, by putting these points at one location, now you can't apply moments in yaw, but it also doesn't matter because we're not trying to control that. So ideally those would be like spherical bearings, and it's all like right on top of each other. Realistically, it doesn't have to be exactly that for this to still effectively work. But this would work for the frame that this triangular prism frame. The problem with this is you give up a fair bit of vertical stroke because these nodes are up and down on top of each other. So what I really wanted to do was a frame
that looks
like
a lot
this,
more similar to what I've seen online.
Yeah, they tend to cross them and they go up and down. With 8 strings, you kind of move them to different nodes on the top and on the bottom of the little cubes or cylinders that they use, so these strings don't interfere. So this is a little bit of a trick with this one because these strings want to rub at this point and they can't cross, and that kind of ruins things. So what I was trying to do was a frame like this, where you turn the triangle the 30 degrees to shift it over. This seems like a really good answer, and the frame tends to get kind of annoying and complicated.
Yeah. And that does not tessellate very nicely at all.
Well, yeah, you can kind of stick it next to each other, but I agree, it's not as appealing. And then what I really want is the string to go over the pulley, which I'll show you in a second, and then down, straight down. And it could be like down on this taper, but basically on a vertical rail. So from this node on the bottom, it should go up and like follow the kind of design of what we're doing with the hand capstan. I think it's a really good way to do it. But if with one pulley, it's better. I don't want to have a second pulley to turn it and do something else if we can help it. So then I started doing like, I can like do all these funny things. And well, it's some of these aren't there. I'm like, this is just an example of like, how do I get this vertical rail, but get this node over here? I think I had another crazy one.
God, that looks like
Anyways,
such a pain.
I was like, I think we can 3D print nodes and make something that's cool. But like I kept coming back to this frame design where you use these 60-degree tapered rails, because then you end up with these simple 3D printed parts.
Yeah.
So this profile rail is really cool.
Oh wow.
And I might as well pick it out because
is that like a standard rail? I guess it must
I've
be.
been building it. Sort of. You can get it from a few places. It's got its that shape, so the sides are the standard size and it has that pitch, but it allows you to do this angle.
I like the Jugglebot red, by the way. It's very nice.
You know, I tried to get these rails in black and I can't find them. The 60-degree rails have to be silver, unfortunately. They spray paint it. I knew you would say that, so I was trying to get the black anodized rails. We'll figure that out.
But honestly, that has been like every time I've been looking at getting things made of metal, the way to color it has been like a not insignificant thing that I've been thinking about.
Yeah, aluminum for everything and anodize it in one lot. So you try to get it to match, but it's always a pain in the butt to get it to match if you're trying to aim for a color. Anyways, this frame and like just handling this is like super rock solid. I'm beyond thrilled with the way this is coming together, and it locates it with here. Let me spin the part in CAD so you can see.
Are all of those plates PETG?
PETG for the plates. That has
nice.
I guess that's right. So I put these keying features in there, which I was trying to do a couple of things. One, to kind of lock the angle a little bit nicer.
Yeah.
But also to get the T-nuts to not rotate while I was assembling them.
So much. So how do you have to like slide this in then?
Yeah, so I have kind of one here. So the goal was so it didn't rotate. It's a little bit too loose, so that didn't quite work. And I think they need to be a little bit taller. So these end up spinning, and it's still a little bit of a pain in the butt to assemble.
Yeah.
I think that can get tuned out. That's part of the second thing that I was trying to solve, but mostly just make it solid. So that kind of locks the angles a little bit better and don't rely on the hole in the T-nut to locate it. So that's one thing. And these side plates are otherwise kind of not interesting. There is... Where did I put this part? I must still be living in the mess of here. Yes. Turn these off and then zoom in on that. So then the other big piece that I was trying to solve is how do you support the bearing and what kind of bearing to use. So this part locks in the same way. There's a hole on the corner that taps into that center hole down these rails. So you can tap M8 for the 30 millimeter rails. Oh, that's another quick note is I upped it to 30 millimeters because I started with 20 and then I decided it was too wimpy at this scale.
Yeah.
So that also helped a fair bit. Yeah, so there's this bore for the bearing. The bearing is a 3200 double sealed bearing. I don't have a good picture of it. But it's a angular contact back to back, or they call them Conrad bearings. So it's like no axial play and no moment play. So it on this swivel, I guess I'll jump over to that.
That looks like a very thin shelf that it's resting on.
Yeah, a little bit, but so I'll show you the section view from the side because you're trying to get the swivel kind of tucked up in the corner pretty tightly.
Yeah, so that's for people following along if you're not familiar with cable robots or like, I don't know, kinematics in general. It's very nice to kind of like stack the axes of rotation so that they're as lined up as they possibly are. And you can see it in this section that John's done now, where the string, when it comes up around the green pulley, I imagine that's done in like just the right spot where it will intersect with the axis of rotation of the orange bearing, so that as the bearing spins around, the position of that string, where the string touches the pulley, should always be the same. And if that changes around, or like approximately the same maybe, if that moves around, then it makes the kinematics a lot more difficult. And that's something that I faced a lot with designing the joints of Jugglebot, is that like getting all of those axes of rotation to intersect each other at a point makes the kinematics actually doable as far as I'm aware. I think there are techniques for working around that, but it seems like it's so much more effort.
Yep. This is one of the challenges of getting the cable robot to be very accurate. So if you assume it's point to point, you get one answer, but then there's like corrections that you have to do the forward kinematics for to figure out what the actual string length is. But more than that, like the string is a little bit elastic. The string can be sagging over long lengths, temperature effects, all kinds of stuff that means the manipulator is not where you thought it was going to be.
Yeah.
But yeah, I think this is one of the bigger ones that you have to kind of get right at first. So you want to correct for this. I think if you just like, I don't know, it might not be that important. It'll be interesting to see.
Yeah.
But the string doesn't come down right on the center. It's kind of offset over. And I just kind of use my gut on like how far over this needed to shift, because what this needs to do is the string, one's going to be down and one's going to be over. And like the tension on the string, see if I can show you, like you want that to rotate the swivel, and the swivel, like these won't have a ton of tension on the lines. So any like friction in the bearing, it makes it like lag a little bit, and that'll be a little bit of a problem. I think it's low enough that it's not going to be an issue. And it's not going to like skip and get stuck next to the pulley, because I think we can keep the clearance in there tight enough.
That problem really grinds my gears.
Yeah, but I think big enough lines and small enough clearances in there, it's designed to be pretty tight. And all this is a pressed in dowel pin and one of these 3 millimeter V groove pulleys.
Yeah,
these are pretty sweet. I haven't used these a ton, but they're pretty magical that you can buy these for like whatever they are, like 10 cents or something.
I've got like a whole I recently made a new purchase of them, and I've got a whole container full of them.
Yeah.
They're so good. They're so cheap, and you can get them in like all different sizes as well. They're great.
Yeah. So I think this is pretty good. I think it's gonna have a problem with like jamming the string, like a big enough string, it'll kind of sit in there and be fine.
Yeah.
But we'll see how this goes. So this
I've
will just be.
actually, if that does become a problem, there's a guy, I think Neil, I apologize if it was someone else, who used to work for like a theatre production and did a bunch of like cable, like these sorts of things, but for big theatre stuff. And he had some really good suggestions for how to like make guides and little like bits here and there to keep the strings perfectly where they should be. So if this does become a problem, I reckon we've got some people who might be able to lend a hand, which will be good.
Yeah, sounds good. But like, there's not that much room for the string is the idea. So this should basically fill up the string, and it just doesn't have anywhere to go is the idea.
So something, actually, while you're zoomed in on this, something that I've debated a lot and like kind of gone back and forth on is whether I should be putting washers between the bearings and the sidewalls. It doesn't look like you've got space there for washers.
I did not.
Are washers a scam?
Washers a scam. That's the title of this video. Clickbait. You need washers to support the bearing on the inner race if there's a lot of thrust load and you care about that friction or wear.
Okay.
In this case, there is like almost no side load, and it's not going to be an issue. And that bearing still on a slippery plastic. So so there it's just clearance. So it can kind of bounce back and forth just a little bit, but I think this will be fine. But if you had a side load on it, that's where you really gotta be a little bit careful with that.
And I've been like toying with the idea of having little printed washers almost that kind of like extend out a little bit just to contact that inner race and then extend out again. So that's what kind of keeps it in place. And those seem to kind of work, but I don't know, they're pretty small sometimes.
I've done, you can integrate that in the wall sometimes. Just have the print have like a tapered and come back out bump. It's a kind of slick way to do it. Tiny little printed parts always suck. So let's see. This is a dowel pin. This is one of my like mechanical engineering tirades to like not use a threaded fastener here in shear, which you could, but this is well supported on the plastic and then also a good fit in the bearings. So this goes together super nice. And I've got this one together. So there's like, it's almost a press fit into the pivot bearing, and then it's basically a press fit through there too as well. So like no backlash. This is like rock solid.
Nice.
And this has been the like fiddly bit of like how to get this to like come together really clean. And I'm finally, I think, happy with it. Well, I'm happy enough that I was like, okay, it's time to build it. Let's go see if it works.
You're building this. It looks like you're building it full scale. Like first up.
I am. We're going. It's gonna happen. Another kind of nifty thing here is that there's a fastener. So this is in tension. This is trying to pull this out of the bearing. So I originally was trying to figure out how to make the shoulder be loaded so that it didn't need this fastener. But I think this is just slicker, the way to integrate it. So settled that this was the answer. This will like press in, so it'll take a little bit of force to push this in to the point where that's probably actually enough to hold it together, is my hope. And then probably also put it together with a drop of super glue to fill the gap. But then for retention, there'll be this fastener 4mm, and then tap this hole. So that pulls it up, and use a big washer to support that. So that clamps it together. That'll give it a little bit of preload, like put this into tension and make it not want to crack here. So I think that would make it strong enough in PET G, which is fine. But I got a pack of the CF nylon.
Yeah, I've got one of those as well, but I've heard how hygroscopic it is, and I've been terrified to open it.
Well, there's that, but I get a food dehydrator.
I do have one actually.
This white thing right here.
Yeah.
Is a $20-$30 food dehydrator, And it, like, I was worried like the temperature control and stuff is like a big deal, but I just turn it up to max, and that's like 80 Celsius, and that works out okay.
Yeah. No.
Yeah, so that's working pretty well. This came in the package with desiccant, and I just still put it in the dryer anyways. But like, so that was one thing I worried about. But also, I've heard just like it can be a little finicky. But it just printed and was awesome. So
Nice.
I don't know. It's
So
really
good.
good, and it's way stiffer. It's like unbelievable how much stiffer it is than.
That's amazing that you
PDF.
can. It's so much stiffer that you can actually notice it on such a small part.
Well, right. So like, there's this clevis, and I can like squeeze this and feel that it feels squishy.
Yeah.
Squishy for my aerospace engineering
Yeah.
stuff. But you know, it's like very noticeably stiffer, and also
Yeah,
the
wow.
properties are like 2 to 3x the strength ish, 2x.
Yeah.
So it's like for parts like this, it's really good. I don't know if I would bother with doing it with the plates, like if we really
Yeah.
decided the thing was rocking around, maybe. But at that point, I would probably do diagonals, which I don't think it needs. I think it's going to be just fine like this. So it'll be wide open. Yeah, so this is pretty good. One last note is, instead of this fastener on the bottom, it will get one of the little swivel feet. So this will have like an adjustable little foot that you could level it, but
Yeah.
you also just electronically level it to give it its up and down.
Nice. Very cool.
So that's
Super cool.
probably the tour. Oh, I wanted to say one quick thing about the magic of using a different material for support. Another plug for the AMS for bamboo carbon. It sounds like an ad for the bamboo carbon, but I am not getting paid by that. So PLA on PETG works wonders. So this is one that just kind of popped out here, and it literally just is like a shim that falls off.
Oh my god.
So it just sticks enough that the part prints. And then
Did you print that part just for this example? Like, that looks like the sort of thing that could just be printed flat on the bed.
No, so what that is the inside of the bore. So you'll have to go puzzle over all the little decisions on how this gets printed. But so this gets printed flat on the bed.
Yeah.
And I've always in the back of my mind designing parts for 3D printing, like, how do you get rid of all the overhangs? I need it to be tapered. And well, if you can do this, you'll decide that you don't need to do that anymore. Because it's really just wonderful. It takes just a very little bit to pop it out, and you end up with like a really nice surface finish, because you print with no gap and no space, so it gives it like that interface layer, and it just pops out. This is a little tough because it's kind of like right up against the wall, so you have to kind of work it out. But it, yeah, if it's a separate layer, it just peels right off. So
it seems like you could even like decrease the radius of the support area just a smidgen by like 0.5 millimeter or something, so that it's not right up against the walls.
Yeah, I think that's part of why it got stuck. There's a variable for that, and I think it's probably just a touch too close, and that's where it's sticking. But it doesn't really stick at all on the top.
Yeah.
But I was like, you want that surface to be supported, so I don't know. That's kind of why I had it all the way up in there.
Yeah,
but it only does it
good
at that top layer, which was the key. I was always like, the support material being a different material, it has to switch back and forth, and then it like poops out this little, cubic centimeter of material to switch back and forth. But if you only use it for the interface layer, like a relatively small range, it works really well.
Right.
And it does 2 layers of the new material, and then switches back and does 2 layers of the other material. So you can use it if you really needed support over like a curved surface. But it, like, switching back and forth between filaments is like a kind of a bummer, because it takes really long, and it is just a waste, especially for like the nicer filaments that are kind of expensive.
Yeah. Has it been perfectly reliable for you, that switching?
Pretty reliable, yeah.
That's pretty good. My printer can actually do that as well. So if I go to this view, you can see I've got this big like box on top of the printer station that has 5 filaments. And so this was an older Prusa design where they called it the MMU, the multi-material unit, and you can swap between 5 filaments, and it works. Kind of. I use it for just like having 5 filaments ready to go at any time, but I only ever print with 1 filament because it's just so unreliable. I've had a couple where I tried, like right at the beginning, I tried to do a bunch of multi-material prints and having to swap more than like 4 or 5 times, which you have to do. Like some of the prints had like 100 or something swaps. It would just like get jammed, and then I would have to go there and help it out. And like every time I have to interact with it, it's just like, no, this is not feasible.
It's not worth it.
Yeah,
Well,
so it's good to hear that the Bambi one is a bit more reliable.
Well, even for yours, I would absolutely try PLA and PETG as the support for each other just on that top layer. Give it a go. It's absolutely worth it. And then PETG with the nylon works too. So you don't need their like support material.
Yeah, that's cool. Yeah.
So
that was the other thing I found. Like the dissolvable filaments never really seem to dissolve very well for me.
No, it takes too long and doesn't really, just kind of makes a mess. So
yeah,
I think there are better dissolvable stuff, but I've never been that impressed with it. And this is just better. So you don't need it anymore. So the last bits on assembly of this is that to drill this hole to avoid the issues with the cross hole when this is getting printed, I print that solid with a little dent in it to start the drill. And then I made a little soft jaw, and you love flexures. So here's your flexure. So I've never done one of these before, and I think this is great. So this is a soft jaw fixture to hold the part. So I'll go put this in the vise in my drill press, clamp the part, and
it's a bit out of frame. Oh, there we go. Oh wow, nice. Yeah.
So looking at my face, there you go. So you clamp on that in the vise and it holds the part, and it's just the negative of the part. So it's pretty easy to design.
Yeah.
But it's connected. So I would normally do these like aluminum soft jaws, and you can machine kind of the negative of part of the part to hold it.
Yeah.
But that's CNC. If you don't have a CNC, then you can't do that. But you can actually use this to like machine a part too. So I've seen it done, and it works quite well, just less precise. If you don't need it or can kind of locate on your part, it works. But this will hold it really nice, and then the cross hole becomes a very nice fit for that pin.
Perfect. Yeah.
Which is important for all this precision. So I think it's gonna be awesome.
Yeah. I
agree. Next, I'm gonna finish building the frame, string it up to just like tie them off, and then the question is what is the hand platform gonna look like? But I just want to like tension them by hand and then get a feel for like how stiff this is, and this is all reasonable, and then start thinking through motor mounts and that next iteration of that, which now has to be mounted on this 60-degree rail. But I think that's a easy problem to solve. Question is which motor. I'm tempted to use the existing.
Such a hard
question.
There's so many motors out there.
I think it's a little undersized, and
the hand motor.
Yeah, I think to upsize it a bit, it would benefit at this scale. So
yeah, that seems
just give
appropriate.
us less to worry about. So I think bumping it up is one way to make that happen.
Basically zero inertia is quite nice. You can just like get up to speed instantly.
I don't know that it matters so much, because the torque to inertia ends up being reasonably constant over reasonable size changes. So the pulley gets bigger because the torque is higher. So I don't know. I'm curious how it actually scales. So now we have motor well characterized. So with the bigger one, I don't know if it gets better or worse. I think it's going to be reasonably close to the same for an equally high performing motor. But the downside is it's an outrunner. So all the inertia is on the outside of the magnetic air gap. So torque to inertia ratio is crummy for an outrunner compared to an inrunner of an equivalent magnetic design. So you're asking, where do you go to try and make this better? Why is John so crazy about this and thinks it's so fun? So a like frameless motor that they use for these robotic actuators is what I was spying. So I'll put together a little write-up, and if I decide to go through with it, I think it eventually needs non-printed parts to make that work more than just be a prototype. But it's like almost an order of magnitude faster.
Wow. Okay.
The
like
torque
acceleration?
rating. Yeah.
Yeah, wow. Very cool.
So it would be, I think, a substantial improvement in speed and moving the thing around the envelope faster. I don't think we need it to do what we're trying to do, but it sure would be fun. So maybe that's a thing to do. But I think initially it's take some of these outrunners and make it go. One of the things that it would
especially
help
like
with, I
with
think, is
these
they
the hand motors are so cheap. Like I feel like it's, and I'm sure you already have a bunch of them. Like I bought like 10 when I first bought them. I think that is a very appealing
yeah.
thing for me. It's so easy to just like whack them together and then at least try something out. And then if we need more power, we can just upgrade.
Absolutely. Yeah, so the one I was looking at, I think it's like sort of double to maybe a little bit more than that, but it's just for like the stator and the rotor. So then it's going to end up being a fair bit more money for the actuator. But it gives you the opportunity to like make a single shaft that's the spool and the rotor for the motor mounts on that, and the magnet is bonded into the end of the shaft, and you can make it all out of aluminum because you don't really need it to be steel if you have that much diameter. So yeah, I think it can be pretty cool.
Yeah.
And then you still need an aluminum housing to reject the heat from the stator. That can be printed for testing, but you'd melt it pretty quickly. Yeah, so maybe, but I think we'll start with like a 40 millimeter ish. Oh, I was going to say cogging torque. So the way they like shape the magnets a little bit differently, and a lot of the cogging torque can go away by using
Very
a motor
cool.
that's designed to have less cogging torque.
I've seen some where they have the magnets kind of like spiraling around or like on diagonals, and apparently
so
that seems to help a lot.
Yeah, you can skew the magnets or you can skew the stator, so it kind of smears that out. You can also kind of round over the magnets a little bit, and that gives you a less sensitive, because what it's doing is the magnet's is attracted to the iron in the core.
Yeah.
It's going over each lump, and they're all out of phase. So some are better than others, but there's some tricks to kind of get it all to balance, and then you don't feel it. Or the ironless stator. So they're like Maxon motors, and there's a handful of others that do it. So it's just copper in the stator. There's no iron. So it's less torque dense in terms of like the magnetic field strength, but they kind of compensate for it by throwing a lot more copper and just the magnetic field strength straight from the coils. So they can still get it to be pretty efficient and high performing, ditching the iron, and then there's nothing for the magnets to stick to. There's no cogging torque at all.
Yeah, wow. I imagine the control is a fair bit harder for those though.
Yeah, there's less inductance, so the controllers tend to be like 50 to 100 kilohertz or higher for the tiny ones. Yeah, it's not your run-of-the-mill brushless controller to run those typically, or they get really hot because you just have all this ripple current.
Very cool.
So I don't think we'll go there. We'll try not to spend all your money, but the goal is for like a reasonable budget, and then you can stack 2 of them next to each other and juggle 14 balls, and then you can stack 6 of them around each other and do whatever you want.
I love the tessellation. I don't know if you've still got the stream open, but Ian said the same thing, that he loves the triangular design because of how great it is for tiling, and I agree.
That's half of what I like about this.
Yeah, and I like that because it can't extend outside of its outside of that frame volume. Like the hand is always going to be in there, so there's no risk of like putting them right up against each other. They just can't touch each other.
I think you can even like build these nodes into one, so like this can be shared with the next one and do some cool things.
It'd be cool to do like below the bar juggling and like above the bar. That would be an interesting obstacle.
You were talking about the hand-to-hand transfers. I do think this will be capable of
that
tilting
would be
the over far enough.
Very interesting. They're called one throws in juggling. It takes 1 beat to pass horizontally, and that opens up so much. Like that's one type of throw that I have thought that I've just been assuming Jugglebot will not really be able to do for a long time, but yeah, it'd be very cool if it could. Like being able to do like the shower is such a cool trick, but it's critical that throw is possible. That'd be pretty awesome. That'd be very, very cool. Actually, while I've got these out, on the topic of balls, I have actually bought some Russian style balls after talking with Kai about this. I don't know if you remember. There's a dude in Germany who's also working on building a juggling robot for his PhD, and yeah,
Nice.
he suggested to look into Russian balls, which are like they're basically like play pit balls filled with sand. And I've bought a couple, but the only real sellers of them are in Europe, so I think it's going to be a little while before it arrives. But from what I can tell, they seem like they are the correct type of ball to use. So I'll send you a link. I'll post on Zulip for which ones I got. And yeah, I think it'd be a good idea if you wanted to pick up some as well.
Yeah, I'd be interested to see how they compare to the ones I settled on. I have a pack of these. They're kind of beanbag balls, but they're a little squishy. They're pretty similar to your orange and white balls from what I can tell.
Yeah, these got like a little bit of play. I think that really like the Russian balls I think really benefit from having the hand being the right shape, and the hand being the right shape really benefits from the Russian balls. Like they kind of like work together really well. And
Okay.
what I mean by like the right shape hand is just like a big cone basically, where because at the peak it's a tighter, like because it gets smaller at the peak, the spherical ball can't get the whole way down into the cone, and so if it rolls down the side, it doesn't like roll up the other side again. It will just like seat itself perfectly in the bottom. And because these Russian balls have sand in them, if the ball tries to like spiral around the cone, it won't get very far because the sand rolling over itself is just going to dissipate all of that energy. And according to Kai, the ball like locates itself in the perfect spot, in the exact same spot, pretty much every single time, like very quickly.
That's exactly what we want. Yeah, that's really good.
Yeah.
And I'll say, when you showed me the shape of that hand, that was like in sketching up some stuff. Like I was kind of converging that a cone like that and just playing with the angle and having kind of a flat bottom. So I'm glad that's clear. I think that's playing with that and getting it dialed in for the type of ball is that's going to work really well.
Yeah, definitely. And that's why like I have a bit of concern of using these sort of like hacky, like the balls with a little bit more pliability, because I don't think they would seat themselves as reliably, and they might get like jammed. If they fall in really quickly directly into the center of the cone, it might get a bit stuck in there.
Yeah, but I don't know. It'll be interesting to see. It may end up working okay. Like, as long as it plugs itself in there, and then the hand has a long enough stroke to kind of get it collected up and going where you want it, it may still work.
Yeah, definitely have to test.
Well, yeah, it'll be
lots of
interesting.
testing. Yeah. One other thing that actually might be worth mentioning with respect to the hand is that Kai mentioned that he's actually been toying with the idea of having, rather than having a cone with a nice flat curved surface, having a bunch of facets, like an octagon or something, that has kind of like corners to it, so that way when the ball comes in, rather than being able to, like, even though the Russian balls have the sand and everything, they can still spiral a little bit. But if you have like corners for the ball to hit, then it will dissipate that energy even more. But of course, that will maybe make the ball bounce around a little bit. It sounded like this was something that he's starting to explore now, but hasn't really gone into much yet. So it could be interesting for us to check out as well.
Definitely. Now, I'll say, I think getting the hand exactly in the right place at pretty much the right speed kind of solves all problems. You'll be able to rigid ball if you get that dialed in. It just makes it more tolerant of error. So then like the vision system and all of that, like you can kind of trade the like how well that needs to work. But I do think we're going to end up wanting the tracking systems, and
it'll definitely help so much. I really would like Jugglebot to not require motion capture for its operation, but definitely, like I'd be very, very, very satisfied if we could like train it, or like do the development with the motion capture, and then get it to the point where it doesn't need it, and then it can just like go blind afterwards or something along those lines. Have like a less good vision.
Exactly. And if the robot hardware is really good in control, it can put the ball right where you want it, and the hand just reaches out and catches it, then that makes it very easy. but that's not juggling, right? It needs to see the ball and catch the ball. Like it can't juggle with you if it doesn't, it can't see the ball. Because one of the things that I'm very excited to see is to be able to throw the ball into the center of it and just have it catch it. I think that's the bar of we've made it.
I think that should be possible. This maybe like beginning like early next year. Depends on how long it takes to get like mocap organized and set up and everything. But I feel pretty confident that I'll be making a purchase of it soon in the next couple of weeks, which excites me to no end.
It's very exciting, and that stuff is all way better than what you can sort of I'll say cobble together maybe out of machine vision cameras and the software in ROS. But I do think you can do pretty good object tracking even without that. So it may be possible to do with basically out of the box object tracking. And the trick is like getting the cameras to be well behaved and timing, because everything happens really quick. So you need the pictures to be synced, and then resolve.
So I've been looking at how to reduce like what the different latencies are for these different systems, and it turns out a huge amount of the latency is just like in the camera itself, just in like the exposure of the frame. And then within the cameras, they do, I think for both companies, they do a bit of processing just to like get the 2D coordinates of all of the trackers that it can see, and then it sends that out to the to like the main computer. And what's kind of grinding my gears a little bit is that for both of these systems, I'll have to have a window, like a program open on my Windows PC, the one that's currently doing the streaming, and then that can get streamed out from there to the network, which then Jugglebot computer will be able to see. And I was thinking like, do I really need to do that? Do I have to go through this like Windows program? Can I just like do it straight to the Linux computer? But and you can do that for one of the brands. I can't remember which one it was, but for one of them you can do that. But that requires getting the data straight from each camera. So I'll just be getting the 2D view of what each camera sees, and then I would have to manually do like the combining that into the 3D data. And I'm like, there's no way that I will be able to code up something that's more efficient and faster than what they've done. Like this is their job. Like I guess I'll have to accept the two computers.
And not only that, they're using like graphics processors to parallelize the processing. So I'm sure it's pretty dramatically helping the speed of it all, which I think you can do some of like in the Jetson. But yeah, it's a whole thing. It's not trivial.
Yeah.
So, but I don't know that like the latency might not be so bad if you can get the pictures to happen all at the same time. So like a hardware trigger on 3 cameras, get the pictures in, when they were taken. Now you process that and figure out the trajectories, update the trajectories of the ball even 30, 50 milliseconds later. It only needs to happen.
Yeah, honestly, like it is fine. Like it's all on the order of like 4 to 7 milliseconds. So like, it's going to be fine, I think.
Yeah,
especially given that like the ball is in the air for like a second, like a millisecond is.
You've got a long time. Yeah. Now, I think a lot of the challenges with lots of balls in the air passing each other, deciding what's a ball and not a ball as they cross each other in the field of view is kind of an interesting problem.
I think with enough cameras, that shouldn't be a problem.
Well, you need to make sure you're throwing out the spurious data, I think, is part of it. And maybe those are good at figuring that out.
Yeah, these systems. So I actually went to one of the reps has like a place, like a brick and mortar store kind of near where I live. So I went out to visit them yesterday, and it was very cool seeing that setup. And it's impressively good at handling occlusions. I mean, their setup had like 12 cameras in there, and there's no way I would get nearly that many. But
these are the reflective
spheres, the little retroreflective spheres. Yeah.
Okay.
And I think what we would do for the balls is to do what Kai has done, where he's got retroreflective tape, and he's just like completely covered the ball in retroreflective tape.
Oh, the whole thing is
the whole ball. Yeah.
Okay.
Which is good. This is another reason why I don't really want to rely on motion capture in the future, because I really want the LED balls, and I don't, unless we like I'm expecting to have to like make my own or like Jugglebot specific LED balls, but I can't imagine how that would work with the tracker as well as the light coming out. I think that would be, it's like I want light going in and then also light going, like a different kind of light going out at the same time. Like, I don't know, but that's a problem for a while away.
Another day, but this is ringing a bell. So you know how street signs are very reflective from the source of light? So they have these like little retroreflective particles in there. I don't know, the shape of them is the magic, but I think you can like paint them on. But if you could coat the ball with that and then you shine the light at it and it's reflective.
I was thinking about this actually, having like a very fast like projector almost that shines light onto the balls, and that way like the balls might be like white or I guess like retroreflective, and if we have like lasers or maybe something a bit less intense than a laser, like colored lights, that could be a way to light up the balls, definitely. But the tracking on that would have to be so quick. Like for the light, for that little circle of light to be like just on the ball and not like leaking out.
Yeah, you just want some light from below. I mean, that's the thing about the just vision cameras is like if they're just colored balls and you have to be careful about what the ceiling looks like.
Yeah.
They're like, it's pretty easy to tell where the ball is and that it's.
But getting the 3D data on that is tricky. Like I've got some Oak depth cameras, and so it's like the two cameras on the sides will both track it the same, like both look at the same time, and then like by the same way that our eyes work, basically just like combines it into 3D. But I found that the depth data on these to be not really reliable enough for juggling. Like you can do 2D positioning really well, but the 3D it really struggles with. I think just because these cameras are so close together.
That's exactly it. Is the baseline is huge for how accurately it can see in 3D. So the cameras can probably get to be pretty crummy if you put like on top of the triangular frame 3 cameras that are kind of looking up and in. Like 600 by 400 might be enough to be helpful, and then if it's 5 megapixel or whatever, becomes pretty good and actually improving significantly the trajectory estimation of the ball.
And that doesn't even need to be that good. Like I don't know if you remember my Kalman filter little code that I had for predicting the path of the ball, and I've done a lot of playing around with like how accurate the like initial conditions of the ball are versus how accurate the tracking data is, and the tracking data doesn't need to be that good to have the ball land in the right spot, as long as it can go at like a relatively fast frame rate, and as long as the ball is in the air for like a little while, it hones in quite nicely on where the ball will land.
Yeah, I think it would be like that. You'd have a model that's predicting its trajectory, and you use the camera updates to nudge it in the expected location. So now you're just predicting forward when the ball crosses the catch plane, and you use that to predict the catch location, and now you know the hand location and velocity that you're targeting, and now you need the hand to follow that trajectory and get there on time. All that.
So Ian is suggesting retroreflective spray paint, which I guess is a thing. That would be handy.
Especially if it's clear coat. If you can just spray any of these balls and have them just glow and you don't really notice it looking at the ball, that's probably the magic trick.
That would be amazing. Yeah, and James is saying that a robot juggling without a hand sensor is like a human doing it with numb hands, and it feels like it will be a much harder problem, which I agree with, but I don't know, have you thought much about getting a sensor on the hand in the cable robot? It seems like that would be easier than with the current setup, because like you could run a cable up in a similar way to how I've got the spiral cable running up to the platform right now.
Are you saying a sensor to know that the ball's in the hand?
Yeah, but I guess vision would kind of do that. Good enough vision would do that.
I don't know if the cameras would want to point down at the hand. I've been picturing that like it's going to sort of leave the field of view, and then the hand is going to do the rest.
I should clarify what I mean by I've been kind of like committing myself to the idea of having motion capture, and actually to give you a full perspective of what I am thinking. Let me go to this camera. So I'm thinking I can put. I actually also had some people who works for one of the companies. They actually came here a couple of days ago as well, which was pretty cool. And they were like giving suggestions on what I can do with my space. And I think the go is to have like 1 or 2 cameras along this wall, which faces Jugglebot down here, and then having, depending on how many cameras I get, either 3 or 4, having another one like up there, and then another one on the same wall on the other side. So it will have a very solid like front-on view of Jugglebot. It'll just be like seeing the entirety of the thing. So that's kind of what I mean by like good enough vision in the form of motion capture, in my mind, should kind of like remove the need for sensing on the hand, because that sensing would be the vision. It's kind of like if you were juggling and you could see up as well as seeing down at the same time, like, which we obviously can't do as humans. But
yeah, the vision system's going to be cheating because it can see everything and have 3D accuracy, and
to
it's going to be impressively good once it's dialed in. Yeah, that's the goal. Yeah, and I do think like if you can get your hands on something like that, you're not solving that problem. Like this is a whole like graduate level research kind of thing to get this working really dialed in. So if you can get a partner or can swing it and just buy it, I mean that's going to be better. Then you're working on the other pieces of it instead.
Yeah, I'm very, very keen for motion capture. It's gonna be good.
I think so.
Cool.
All right.
Well, thank you for the update. I am very keen to see that this is still ticking around. It's great.
I certainly stay busy between family and my job, but having a hobby like this has been super fun.
Nice.
And I do want to see it juggle here too. I think there's going to be a video where I juggle, I throw the ball, and then it catches in Australia.
That would be pretty cool.
Forth. Yes.
That would be very, very cool.
Yeah. All right.
So much to come.
I agree. It's a cool project.
Yep. Cool.
All right.
Well, thank you very much for your time. And yeah, we'll keep in touch on Zulip.
Yeah, definitely. Take care.
You too.
Bye.
Bye. How good is John? All right, let me take these off. I've got one more thing that I want to show you that I meant to show you before, and I probably don't really need to, but I like it a lot. It's something that I'm very proud of, that I've done. I'm very happy with. But before that, Hooks is saying, if the motion capture uses infrared, then you could use IR reflective paint or the balls and still use visible LEDs in the balls. Yeah, the motion capture does use infrared, but I think the problem is that the motion capture systems, they look for spheres. So, or more correctly, they look for circles. So each camera can obviously only see like a 2D frame, like what you can see of me now. And they basically just like pick up circles in that frame. So if I have this as like a retroreflective marker, it will pick up that circle. So whichever way I orient this is always a circle, and it picks out the centroid of that circle, and then it says that centroid is where this object is. And as long as at least 2 cameras can see it at all times, I can move this around and it will always be this object with a center at that centroid. The problem is when you start, and that's actually why all of those markers are spherical. But if you start putting retroreflective tape on like weird shaped things, like maybe a rectangle would still work kind of well. But if I did like this screwdriver, then it would be picking up the centroid, which will be different based on which way this is oriented. So it would not work as reliably for telling us the actual position of this screwdriver. So if I wanted to do something like this, what I should actually do, as far as I'm aware, is to just put a bunch of markers on this in different spots, like a bunch of the spherical markers in different locations. So the reason I say all of this is because even though infrared is obviously different to visible light, and the visible light shouldn't affect the tracking accuracy, if we have an LED ball like the ones that I've got, we would need the retroreflectiveness, whatever that is. If there's like a clear coat spray paint that we could use, that would be perfect. I've just kind of been assuming that that's not a thing, but if it is, that'd be amazing. But if it's not, like if we have to use like retroreflective tape, like what Kai has done, then that covers the entire surface of the ball, and so we can't see the light. But maybe, like I think with what Hooks is saying is like maybe we could cover portions of the ball and have those, and then have the light, like the LED part, come out from behind those portions. But I think if we did that, I don't know how that would track. I don't think that would track very nicely, because those portions would have to be like equally visible all the time. And I think that the software is like pretty much hard coded in such a way that it will always find the centroid of each circle. So if this had like a bunch of dots on it, it would be tracking each of those dots rather than like this as a collective object. Although you can group trackers. Actually, maybe that would work then, because you can group trackers to be like one rigid body. So maybe covering the ball in like they sell these little retroreflective dots, like little sticky circles. So maybe covering a ball with a bunch of those could work. Potentially, that's a good idea. Paint the whole ball. Yeah, but that if the paint is transparent, then yeah, that'd be great. But I don't know if that exists. Anyway, the thing that I want to show you, I'm so happy with it. This is such a nothing thing, but I love it. So I've been controlling Jugglebot with my Space Mouse a lot, which you've seen. But this is kind of annoying because I need this for my CAD work as well. So I've always, like you may remember, there've been a lot of times where I've like forgotten to change the dongle for this, that I have to like move it from my Windows 10 PC over to the Linux Jugglebot computer. And like having to change it back and forth is just like, no, that's super annoying. So what I've done is I've bought another Space Mouse, just a little one, and I've got it hidden away. So it's like, oh, my desk is nice and clean. Well, actually not really, but it's not burdened by extra space mice. But if I want to control Jugglebot, I can just go whomp, and then magically I have another Space Mouse. And this is just like magneted on here, so I can orient this depending on the way that Jugglebot's facing, so that like each direction is always mapped correctly to the direction that Jugglebot's actually facing. It's so good. I love it. This makes me really feel like I'm in like a spaceship or something. It just feels, it's so nice. This is something where I'm really thinking of like, the more things you have, the more stuff you can do. Because that, like this magnet mount is actually part of it came with like my screen that I'm using down here. It's like this is magneted onto here. And so this magnet is like basically the same as that one. But only because I have this screen do I have this magnet thing, and only because I have that, I can do this awesome little swivelly pocket. I love it. It excites me a lot. Anyway, that's it. Lots of fun stuff happening. I will try to bring myself to start working on the code. I think that's the right thing to do. I'll postpone my camera stuff. I think I've got to get more familiar with using the camera and like how to frame shots properly and how to get the lighting good before I really commit too much to building this entire jig to move the camera around. Yeah, all right, that's the right thing to do. All right, cool. I hope you found this interesting, as always, and good luck with everything you're doing. And I'm fairly certain there'll be a stream next week, so I'll see you then. Till then, have a good one.